precision arithmetic. If you want to use double precision arithmetic, that is an extension. So your code has to basically test to see, does my target device have double precision, yes or no? And if it doesn't have it, and you need it, then you have to do something else, or you have to tell the user, sorry, no can do. And so with OpenCL, until things become a required feature, they will live in this sort of never land of being an extension. And probably they'll remain that way until enough of the vendors implement it to make it worthwhile to require it in the base OpenCL. And so we'll see how that goes. OpenGL has been this way for decades, so it's reasonable to assume that it will progress in a similar way.
At GTC, that's exactly how they presented it. They presented it as this sort of common language that is, one day your cell phone has the ability to run this sort of code that it would be able to, no matter the device, it would be able to run it. So I don't think they've ever presented it as a high performance. I think the feeling I got at GTC was that we can run anywhere. We want to be the Java of,
that's right.
of GPU languages.
Yeah.
Certainly not high performance.
Although, GTC is sponsored by NVIDIA.
Yeah,
if you talk to AMD about OpenCL, they may have a different.
Right. True.
Different
True,
vendors
but
definitely
the
have a
guys
different
that work
perspective.
there from the group, what is it that they are?
Chronos. If you
Chronos,
so
yeah.
to give you an example, if you listen to if you listen to Intel's opinion on OpenCL, it's very negative. But it's because they don't want OpenCL or they just like it to succeed because it competes against all of the stuff that they would rather that you use. So it's difficult. The vendors are all telling you the story that's most beneficial for their sales of their hardware. So keep that in mind.
But from portability, and you kind of rock in a hard place. You don't know which way to start if you're starting now.
Well, I will say this. So having done both, I will say this. OpenCL has a lot more bugs right now than CUDA does. That's to be expected. It's 3 years younger. It requires far less code, and you'll see this. That's why I gave you guys the example programs. If you look at the code it requires to get a hello world running in OpenCL versus the same thing in CUDA, OpenCL is probably an extra 500 lines of code just to do hello world. Because, and there's a reason for this, OpenCL, the way OpenCL is designed, it almost exactly mirrors the way OpenGL was designed. So the routines for compiling the little programs, registering them, getting handles to functions, and all this sort of wiring to get it all set up to run your kernel is almost exactly the same as the way they do it with OpenGL. They changed all the names and a few of the things are different, but it's very, very, very similar. With CUDA, they said, no, let's forget about OpenGL. In fact, they took sort of a different view of let's pretend that this graphic stuff doesn't even exist. What if you look at a clean sheet of paper, how do I make this easy to use? That's what they did. So they have different motivations, I think in part they made OpenCL build on the existing OpenGL infrastructure so that it would make it easier for vendors to implement it, and they wanted it to be accepted as a standard as rapidly as possible, so they didn't want to do anything too unusual or unique, and so that was the safe path, and so they've done that and it works. But it does mean that when you're just getting started, it's a lot of hassle. Now you can definitely steal all of the OpenCL code that I gave you guys for whatever it's worth, and then hopefully you have less of it to write if you decide that you want to use OpenCL. My personal orientation is I always write everything in CUDA first because it's just less work. So that's what I do, but I'll leave that decision to you guys. It depends on what you're trying to accomplish. So if you know from the outset that you expect your code to run on everybody's GPU, then that would be a reason to use OpenCL from the beginning if you think it'll save you time later. But if you're just trying to determine, for example, can my algorithm run on a GPU? If you don't even know the answer to that question yet, or if it's very questionable, that will it pay off, will it get a good speed up, it might save you time to just do it in CUDA. I will say this too, you can basically, the two languages, when you write an OpenCL or a CUDA kernel, the kernel source code, that's the code that gets compiled and actually runs on the GPU, that code is so similar, for basic programs at least, that you can actually convert a CUDA kernel to OpenCL with a simple awk script. because really all you're doing is changing the names of a few functions. There are about 15 or 20 functions that have slightly different names, but the rest of it is almost the same. There are a few extra things that CUDA has that OpenCL doesn't. There are a few things that OpenCL has that CUDA doesn't, but by and large, they are almost directly analogous. And so it's very easy to do that. And in fact, there are free tools out there that will do the conversion back and forth. So that you shouldn't worry too much about which language. Use whichever you prefer. That's
So when you say 500 more lines, where do you add those?
Those are the code that runs on the host. So that's, what GPU, so it's all this code that you have to write for OpenCL that says, what hardware do I have? Oh, I have GPUs. Well, how many are there? Oh, there's 4. Okay, I'd like to use numbers 0 and 3 and 2. That would be great. No, you can't use that one because, so you're dealing with a bunch of this code that does that sort of stuff. It's really mind-numbingly dull and totally unrewarding. It's one of those things you never have to write, but unfortunately, at the present time, there isn't a nice library to do all that stuff like we have with CUDA. Probably somebody could write one out. In fact, by now, probably enough people have gone through this that somebody wrote like a little CUDA emulator type thing that does the CUDA way of doing it but makes it work with OpenCL. That wouldn't surprise me at all. But so that's really what you're talking about, is it's that code to enumerate the devices, allocate and free memory, that sort of boring stuff. That's what's really the boilerplate code. It's just that OpenCL is much lower level.
Well, just calling a kernel in OpenCL. In CUDA you say, okay, I want you to call this kernel with these parameters and these arguments.
And it looks like C code.
And it looks like a function call with this one little thing after us.
In OpenCL, you have to call a set kernel parameter argument, and you call that once for every single function parameter that you're passing in. So that means that you have, for one function call, if it has 20 parameters, you have 21 lines of code right there. One for the call and 20 to pack up all those parameters. So that stuff is headache-inducing. It's really irritating to have to write. That's what you have to do in OpenCL today. Maybe they'll find a better way of avoiding that, but they haven't done it yet.
And the reason is that there is a CUDA compiler which reads the funny little brackets and turns that into something that's roughly equivalent to what OpenCL does.
Yep. Other questions?
We might want to move on to the project presentations.
Yeah, I wanted to answer all the questions first, but if there are no other questions, then I'll let you go. You can bring up your laptop or if you have slides or anything.
Yes.